आइए हम सुने विज्ञान की अनकही कहानियां।
In this podcast, learn how Dr. Bappa Mukherjee's expertise in Himalayan surface geology bridges science and industry, offering critical insights for efficient energy extraction while addressing climate resilience and community needs.
Myself, Dr. Bappa Mukherjee. In WADIA Institute of Himalayan Geology, I am working as a scientist B in activity 2A. We are mainly working in subsurface interpretation, subsurface geology interpretation for basin evaluation, for structure tectonic interpretation, lithology interpretation, georesource exploration, mainly with the presence of hydrocarbon in the Himalayan foothills. And we are having good collaboration with giant oil industry like ONGC, Oil India, and we also procure data from Directorate General Hydrocarbon New Delhi for research purpose only. I actually working on implementation of machine learning techniques, deep learnings, several mathematical tool transforms like Fourier transform, Walsh transform, Euler transform, different kind of fractals to interpret the oil logging and seismic data, exploration seismic data, to expedite the conventional process what our working industry people are working on. So our technique, if we implement into those data set, it will expedite the interpretation time, which is basically time consuming process in conventional. But our process, our technique, if they implement, it will be means faster and time saving. Within a less time, we can say we can interpret voluminous data set with great accuracy. We are providing solutions to the industry people for oil exploration or georesource exploration in Himalayan foothills mainly. So if industry people or some service provider also, if they use our technique, then it will be beneficial for optimum resource exploration. So more or less via industry people and our India, our science community is getting benefited. And during my research career, when I started in WADIA, I also published 2 patents that is for the new oil log tool development. So these tools are having the ability, they can collect the data in a mud filled oil bores. Actually, this tool is basically to find out the image of the borehole. Earlier, the borehole televiewer, I can say. Okay, earlier through some seismic seismic signal or sound signal, they are creating some images. But in our case, and that is to only 1D in a single direction. But in my tool, I have placed a prism, and it having the ability to sense the laser kind of data sets. Okay, so in that case, and that too in 3D manner, so it will collect the data in a more precise way and 3-dimensional way. And in 2024, Paragraphica has been developed, So in the second tool, that is AI televiewer. So I have utilized that AI televiewer and AI Paragraphica camera in this tool, so that with the help of AI, it can generate the details lithological succession below the subsurface. That is very important to understand for the that is very important information for the interpreter in oil industry. During my PhD, I worked in Assam-Arakan Basin. That time I developed several tools, automated tools like bed boundary identification, automatically segregate the potential and non-potential hydrocarbon zones, uh, thin beds, thin hydrocarbon beds, which is also a very challenging issue in the oil industry. During my postdoc study, I worked on gas hydrates in KG Basin, mainly Indian, which is, it is a very giant source of gas hydrates. And whatever the as per Indian resource availability, means how much we have extracted. If we able to we have quantified but not yet extracted gas hydrate in India. If we only extracted 10% of it, we can make fuel or substitute the fuel or electricity bill for the 100 years. Only 10% if we extracted from the resource available in KG basin only. Okay. So, and after that in WADIA, I started my career and still working on the mainly mathematical tool techniques to expedite the industrial conventional interpretation process. And in future in WADIA, I also means applied those techniques into other fields like earthquake prediction, GPS velocity prediction. Generally, in GPS, to establish a permanent or a campaign mode station, it will take more than 15 lakhs. And if we go for the continuous mode, means permanent station, it will take around 30 lakhs. So what we have done, based on the existing network, we have extracted the pattern between the location and the velocity obtained from the conventional process. And then once we train the models, machine learning models, then if we feed the location only, means as our desire or the location neighbor to this already available station, we can predict the velocity there. So we can, in that way we can densify the data, as well as where we cannot able to put any permanent mode or campaign mode survey. Only few people from China have done, but that too not in a reputed journal. But that GPS paper we have published, that one is in Q1 journal, and mostly we are looking for to publish in Q1, Q2 journal only. And in ranking, yeah, we are doing the papers cited by US people, China people, Australian people. They also read our papers. Sometimes we have collaboration, and we all jointly work also. Till date, we don't have any sponsor project, but we have in consultancy, but we have sponsors project from in government of India. But once we successfully do that, we are trying to bring project from oil industries like ONGC, Oil India Limited, and sometimes some private service providers also for data processing interpretation kind of thing we are aiming to do. The research paper, mostly, as I said, that we are published in Q1, Q2 journals. These are reputed journals like Marine Petroleum Geology, Asian Earth Science, Fractals, and in future we are also doing that. One of my book proposal is also accepted in Wiley, so we are working on it to publish in this very soon. That is on the how to implement the several mathematical tools and non-traditional way to interpret oil log data, so that industry people and young minds, our researcher and students get benefited from it.
This podcast series on STEM popularization is supported and catalyzed by National Council of Science and Technology, Communication, Government of India. Produced by Media for Community Foundation. Technical support is given by Soumya Mishra.